couple, we are just going to find, like, manually, we're just going to find, like, find inverse, find derivatives, that sort of thing. Now, the problem is this can only be done with certain types of problems, like problems that are fairly easy to find the inverse for. So what I'm hoping we can sort of see here is sort of working up to finding the answer. So I've asked for very specific things for a particular reason. Here we're going to start with f of x equals x to the third power. So I have given us a table for f of x. I've also given us the table for f inverse of x. I could have probably left this off because you just switch the x and y's, right? So sometimes you won't have that. Also gave us a graph. So for f of x equals x to the third, first thing I asked us to find here is f prime of 2. Okay? So f prime of 2 doesn't have anything to do with inverses, right? So it is just f prime of x is going to equal 3x squared, and then we will plug in 2, so we'll get 3 times 2 squared, and that is going to give us 12. Okay, I'm mostly having us do this here for informational purposes. I want us to see something that's happening here. Okay, I think I actually used the wrong number here. Did I mean to do f inverse? Yeah, I meant for this to be an 8 right here. Let's fix that. This right here should be an 8. I wonder if I did that on the other one too. Oh, I messed that up. That should be an exponent, and this should be a 5. So on example 2, that negative 1 should be an exponent, and that should be a 5 right there. I messed those up. Okay, let me go back here. So that actually should be an 8 right here. So I want to know f inverse of 8. So there are two different ways that you can find f inverse of 8 because I have provided you with both of these tables, right? So one way is that I could go to my inverse table. I could find 8, although I've messed up my table too, haven't I? Because this isn't right. My numbers are not right. Good gracious. This is what I get. Yeah, this should be a negative 8. Fix this. That should be a negative 8. That should be a negative 1, which means this right here should be a negative 8, and this should be a negative 1. Okay, let's fix that problem. Whew, that's what I get. Didn't look back through my work well enough. Here, okay, now maybe we'll be able to finish out this problem. So if I'm looking for f inverse of 8, there's two ways I could find it here. I've got the inverse table, so I could just go like right here. There's 8. F inverse of 8 is 2. Or, let's say they didn't give me the inverse table. If I'm finding f inverse of 8 from the f of x table, I would look in the y column for my 8, and I would go back here and get 2. Okay, now, those things I wanted you to find for informational purposes. The question that we'll really be looking at here is what is f inverse prime of 8? So this is the derivative of the inverse of f at 8. Okay, now for this one, we can do this just manually because it's a pretty easy inverse to find, right? So if I have this here, you could probably do it without even writing it out. But if I switch my x and y's, I've got x equals y to the third. What do I do to solve for that new y? I cube root to get that y by itself. So the cube root of x equals y. That's telling us that f inverse of x is going to equal the cube root of x. You probably could have told me that the cube root of x was the inverse of x cubed without having to go through that process. But I've got this here. Now, I want to find the derivative of this. Before I take the derivative, what is helpful to do with roots before we try to take their derivative? Fractional exponents. So let's make this x to the 1/3 before we try to take its derivative. So notation gets a little difficult here. You got f inverse. I like to put a set of brackets or a set of parentheses around it. So it's f inverse prime of x. But we're just taking the derivative of the inverse, which would be 1/3 x to the 1/3 minus 1 is going to give us negative 2/3 there. Okay, just because we got to figure this out, I'm going to send that back down to the bottom and make it a root. So it is going to be 1/3 times the cube root of x squared. Mason, you mind shutting that door there? Whenever they moved down here, I figured we might need to shut our door a little bit more often. Sometimes I get excited down there. I'm sure they've got it under control. All right, so actually I don't know why I put that equals on there. So they want us to find this at 8, which just means we need to plug 8 into what we've got here. So f inverse prime of 8 would be 1/3 times the cube root of 8 squared, which is 1/3 times the cube root of 64. What is the cube root of 64? 4. So we got 3 times 4, which is 1/12. I may have specifically asked you these questions because I would like to know, is it going to work every time, right? Because, like, there's going to be some where the inverse is way harder. And, like, if you think about that last question that we just did on the inverses, that inverse is harder. Then you'd have to take the derivative of that inverse. And so the derivative of that inverse would need a quotient rule on that last one from your homework. And so it goes from, this is not that bad, to, oh, this is pretty awful, right? So I am noticing that I had f prime of 2, which was 2 is the inverse of 8, right? I had f prime of 2 and I got 12. I got f prime of, f inverse prime of 8 and I got 1/12. So is it always like that? Let's try another one and see if it happens again. And then if it happens again, then we're going to think like mathematicians, and we're going to think of how we can prove that it would always happen. Okay? So we fixed this one here, so it should say h inverse of 5 now. So h is x squared plus 1. It's graphed here for you. We got our tables. I think I did do the tables correctly on this one. So it asks us for h prime of 2. That's a pretty simple derivative. H prime of x is just 2x, and h prime of 2 is going to be 2 times 2, which gives us 4. So if we're thinking like maybe this is going to happen every time, we're thinking maybe the answer is going to be 1/4, possibly. Let's see if it happens, okay? So what is H inverse of 5? We could look at either one. If you've got the H table, you're just looking here, we get 2. Or if you're looking at the inverse table, we got this here, right? Now we want H inverse prime of 5. In order to find that, we would first have to find H inverse prime. Now, this one's a little different because x squared plus 1 is a quadratic that looks like this. And if I do the whole thing and try to do the inverse, I won't get a function for that. So they restricted the domain for that. So let's watch what will happen here. So what I'm going to do is I'm going to switch my x's and y's. So that'll look like this. X equals y squared plus 1. Y is greater than or equal to 0 for that. Okay, keep this in mind. That's our restriction, right? So I need to solve this for y like I normally do. I would subtract 1 from both sides. X minus 1 would equal y squared. What would I need to do next? Square root this. When I square root something, what am I supposed to put with it? I'm supposed to put a plus or minus. I'm going to switch this around. Y equals plus or minus the square root of x minus 1. That's not a function because of the plus or minus, right? We could get two different y values out for x. However, what restriction did we have on this? Y has to be greater than or equal to 0. So what does that tell you about what you should do right here with this plus or minus? It really can't be the minus, right? Because of the restriction that we have. So, our f inverse of x is going to be positive square root of x minus 1. Yes, it is h. Connor's attention to detail is so great today, and mine is so awful. You're going to have to do it sometime anyway. It's going to happen sometime anyway. It will. Okay. Alright. X minus 1 to the 1/2 power. We need to take the derivative of this, right? So, H inverse of x, well, H inverse prime of x, right? So it's the negative 1 on the inside because we're taking the derivative of the inverse and the little prime on the outside. It's really easy to get that notation mixed up, though. And so, what do I have to use to take the derivative of this? What rule would I need here? This is a chain, right? Because I've got the 1/2 power on the outside and the x minus 1 on the inside. It's a pretty simple chain, though, because here I'm going to have 1/2 x minus 1 to the negative 1/2 power. And then I got to multiply by the derivative of the stuff on the inside. But what is the derivative of x minus 1? It's just 1. So they'll probably send this back down to the bottom with the square root. It'll make it easier to evaluate. So we got 1 over 2 square root of x minus 1. Okay, so that's our derivative of our inverse function. Now we would just plug in 5 for this. So H inverse prime of 5 is going to be 1 over 2 square root of 5 minus 1, which is going to be 1 over 2 square root of 4, which is 1 over 2 times 2, which is 1/4. So does it look like our guess is working? Like if I find that derivative at the inverse point, it's just 1 over that is what we're getting for our answer. It appears that that is happening. Now, if you're a mathematician, it's fascinating to me to think of people doing this because I am very good at like learning math that other people have already came up with, or at least relatively good. I'm not like I'm a math genius or anything, but I'm pretty good at it. It's crazy to me to think of coming up with ideas on my own, like coming up with these rules on my own. Now, some things maybe, like I think if I had done enough derivatives with the limit definition of derivative, for some reason, I would have been like, maybe I can come up with a power rule, right? Like, oh yeah, this seems to be happening. But this rule, I would have never probably noticed this at all, because I asked you for h prime of 2. If you were just looking for h inverse prime of 5, nobody would have asked you for h prime of 2, and you wouldn't have noticed that this was happening, right? So it's crazy to me to think that mathematicians are noticing, like, hey, this happens over and over. There's got to be a better way, right? And then, if you're a mathematician, you can't just be like, hey guys, other mathematicians, check out this trick. It works a lot of the time. Mathematicians are not going to be like, sure, let's start using that. They'll be like, prove to me that it works every single time, right? You have to show it works every single time. So we're not going to do, we don't do a ton of this in this class, but I do want to do a proof of this, right? So I think I've shown you guys like some of my papers from college before. Like if you major in math, you have to do a lot of proving of things that you like already know work. So you have to like say, hey, this for sure always works. And they kind of like train you that way. So we're going to do a proof for this. Just so you got like a little bit of a glimpse of it. I think this one's a pretty easy one to grasp. So you got a glimpse of like what something like this would look like. A lot of you are never going to run into proofs in any math classes much, but in case you do, here's a little glimpse of it. We are given that f of x and g of x are inverses. Okay, so in pre-cal we talked about this. I didn't go back over it. If f of x and g of x are inverses, if we do f of g of x, it just gives us x, right? Because f and g undo each other. Think of a really simple example. If f is x plus 5 and g is x minus 5, right? If you add 5 and then you subtract 5, then you just have x left, right? So this is always true for inverses. It's the definition of an inverse. This has to be true for you to have an inverse. It is also true that g of f of x has to equal x as well, but we just need one thing to do here. So if I have f of g of x equals x, I'm going to take the derivative of both sides of that. Okay, so over here on the left side, f of x is my outside function, g of x is my inside function. So when I take this derivative, I got to take the derivative of f. How do I write that? F prime. So it's f prime of the stuff. I don't mess with the stuff. It just stays g of x. But then I have to use a chain rule here, so I've got to multiply by the derivative of g. What is that going to be? G prime of x. Okay, so that is the derivative of the left side. Over here on the right-hand side, what's the derivative of x? 1. Right there. Okay?
Do you not have to do, like, is it just a regular chain rule or is it a double chain?
You could do one more piece right here. There is like one more inside, but if you do, it's just a 1 right there. So you don't have to treat it like that. Now, if it had like a 2x or something there, you would definitely need to do that. There, so you can think of it like that, but it's not necessary for this problem because it's just 1. The thing that we're trying to find is derivative of an inverse. And in this particular case, they told us the inverse is g, right? F and g are inverses of each other. So derivative of the inverse for this particular case is g prime of x. So right here is g prime of x. There's the derivative of the inverse. If I'm trying to solve for g prime of x, what do I need to do? I need to move the other stuff to the other side. How do I do it? Just got to divide, right? So if I divide this side by f prime of g of x, here it just goes away. I'm going to divide this side by f prime of g of x. So that gives me g prime of x always has to equal 1 over f prime of g of x. Now, sometimes you'll get this where they tell you f and g are inverses and they use g notation. Even though the notation is confusing, I kind of like inverse notation better for this because I think it helps me keep straight what I'm doing here if I use inverse notation. So we could do the same thing with inverse notation. I think that'll help us relate it to what we did a little bit earlier a little bit better. So let's go back. Let's do the same thing. Let's use f of f inverse of x. F of f inverse of x is still just x. Here, basically, the only thing we did was replace g with f inverse, right? So if I did the same thing here, if I took my derivative, here's my outside, here's my inside. If you want, you can think of that little x right there as your most inside, but since its derivative is 1, it's not necessary to think of that. So if I take this derivative, I've got f prime of, I'm going to leave the stuff on the inside alone, f inverse of x. And then I got to multiply by the derivative of the inverse. Here's where your notation's kind of ugly. F inverse prime, right? You're taking the derivative of the inverse of x. If you want to multiply by the derivative of the x, it's just 1. Right? And just like we did over here, that just equals 1 because the derivative of x is 1. So to find this, I would just divide both sides by f prime of f inverse of x. Okay, so it is always true, I'm going to use a different color, that if I have to find the derivative of the inverse of x, it is always true that it's going to equal 1 over f prime of f inverse of x. This is something that is very good to memorize, because we will get some where we can't like find the inverse, find the derivative, and plug in a number for that. So if I go back, like if I go back to that first problem, let's go back to that first problem. If I use this rule instead for this first problem, if I want to know the derivative of the inverse at 8, I will get 1 over f prime of f inverse of 8. Like that. And then, if we use the pieces that we found, f inverse of 8 was 2, and f prime of 2 was 12, right? Sometimes we have to do it this way because we can't actually find the inverse manually with an equation for that. And even if we don't have to do it this way, sometimes it's faster to do it this way. particularly, like you'll notice here on the second one, the derivative of our second one was a little harder, right? We had to use a chain rule. It was a little bit harder, whereas usually the derivative of your original function is much easier. Our derivatives on both of these were very easy to find right here. So let's look at the kind of stuff that they're going to have us do. Here's an example. You have no other choice. You have to use like your formula here, right? So f inverse prime of 7. If we use that formula that we just proved, is got to equal 1 over f prime of f inverse of 7. The prime goes on the outside, the inverse goes on the inside. There. So you would have to start by finding f inverse of 7. They have given me f of 4 equals 7, f of 7 equals 5, f prime of 4 equals 1/3, and f prime of 7 equals 2/3. I don't need all that stuff that they've given me. They gave me extras to make sure I knew what I was doing. What is f inverse of 7 going to be? It's going to be 4. I'm looking right here. You're not looking at the primes because this doesn't have anything to do with the derivative yet, right? And you're looking for where the y was 7, and you're going to give the x that goes with it. So the x that goes with it there is 4. So now I'm looking at 1 over f prime of 4. Now I must find f prime of 4. What am I going to get there? What is our f prime of 4? 1/3. Right here. It's just given to us, right? We're just looking at this right here. F prime of 4 is 1/3. So we can replace that with 1/3. They are pretty much never going to leave a complex fraction as an answer. For response, you could stop here, technically. But dividing fractions is easy as pie. We're going to flip the second and multiply. We'll just get 3 for our answer. Okay. Once you get your head wrapped around the formula, these are pretty easy to do, but you have to know the formula, and you have to be careful in like understanding how to find that inverse and everything. So let's look at one where we are going to need to do a little bit of derivative stuff. I don't know how to find the inverse of this. Like if I switched my x and my y's, right? If I switched the x and the y's, I would have x equals 1/4 y to the 3rd plus y minus 1. And I could get all the y's on one side, but I've got one y that's to the 3rd and the other is not. So if I factor out a y, I still have more y's. Like, you're not going to be able to find the inverse of that by hand. There might be a way to do it by hand, but I'm not aware of it. And I'm certain that you guys have probably not ever seen how to do it either, because I don't think that would have, I mean, maybe in 3, but I don't think. I'm pretty sure that nobody did that with you in 3. So we can't really find the inverse of this, which means to find the derivative of the inverse, we're definitely going to have to, like, use the formula for this, right? So, in the formula, like in fact, I might even sort of skip down to B right here. They're eventually going to ask us for the derivative of f inverse at 3. So they are asking for f inverse prime of 3, which means you're going to have 1 over f prime of f inverse of 3. So, the first thing that I'm going to have to do is what they're asking me to do in part A. I would have to find that f inverse of 3, right? Like, that's why I'm asking you for this first. with an equation, it's a little bit trickier, and I'm trying to remember right now whether I need this to just be calculator active or not. What would I do if I were going to do it by hand? I can't find the equation of the inverse by hand. I definitely am not going to be able to do that. If I just want f inverse of 3, if 3 is the x coordinate on my inverse, what is it on my original? It would be your y coordinate, right? So I would have like 3 equals 1/4 x to the, x to the third plus x minus 1. And I would need to solve that and find the x. I'm not finding the inverse here, so I don't have to switch the x and y's because I'm not like actually finding the inverse. I just need like that x value that goes with it. You could call it either one right here, just depending on like how you want to think about it. I'm sort of like finding the x value that goes with this y value, so I've left it with x. You could think of it the opposite way and do it, and you get the y and think of it as the answer. Whatever you solve this equation for is going to be your answer for your inverse. I am pretty sure the only way we can do that right there is some like synthetic division stuff that we are not going to do. We instead are going to follow the pathway of the math 3s, and when we do not know how to solve an equation, or don't feel like solving an equation, or are too lazy to solve an equation, which might be the case here, but it's warranted because it would take forever. We are going to go to the Desmos. So any of the ones that you get on your here on your worksheet that's not what I want. That one. Okay, that are like where you have an equation like this where you're having to solve. If this was a much more simple equation, we'd plug in 3, we could solve it really easily. We can't do that here. How can I solve an equation on Desmos so that I don't have to do this? You could do that, yeah. Usually what I tell, see, I hadn't even given you guys the tricks, because you guys can do this. Here's what I tell my Math 1 kids to do. I tell them to say f of x equals the left-hand side of the equation. I tell them to say g of x equals the right-hand side of the equation. Alright, so I'm going to go over here to the Desmos, and I'm going to type in f of x equals 3. G of x equals 1/4 x to the third plus x minus 1. Right here, this is another reason it's pretty good to have x's if you do y's on that. It'll graph it really crazy. It will graph this for us. What are we looking for? Where they cross. That happens right here. You are solving for your x coordinate. 2 is your answer. So f inverse of 3 just equals 2. So whenever you do this, if you run into something like that and you don't know how to solve it, if it is a quadratic, you should know how to solve it. If it's just linear, like 2x plus 7 equals 5, you should be able to solve that. But if you're getting cubes and different things that are hard to solve, just type it into the Desmos and get your answer for that. We can do it. They won't give you this, and I want you to do it by hand on the actual exam. They would probably give you a calculator if they asked you to do this one. So we just found that this is 2. Now we need to know f prime of 2. Now that is pretty easy to find by hand because I can find the derivative of x, which would be 3/4 x squared plus 1. And then I would need f prime of 2, which is 3/4 times 2 squared plus 1. So that would be 3/4 times 4. I'm going to put my 4 over 1 plus 1. Those 4's right there cancel. I just have 3 plus 1 which is 4. So I get 1/4 for my answer. Okay, everybody okay here? All right, let's look at a couple. Yeah, try this one. Do this one on your own. I'm gonna freeze my screen while I work this one out. Well, only a couple of you got your computers up, and I won't drag them out just for this. You're gonna need an F inverse of 2. Let's do the F inverse of 2 together, so that you have that piece and don't have to drag your computers out. If I'm doing F inverse of 2, that means I'd plug in 2 for my Y. And if we are going to do, from Desmos our way to this answer, this is f of x equals, and over here, g of x equals, you guys should come visit first period where some of us do this for x plus 5 equals 5, or something. But this is warranted here. So if I do f of x equals 2, g of x equals 2x to the 5th, plus x to the 3rd, plus 1. I'm looking for where these cross right here. Oh, gracious, yeah, you're definitely going to need the calculator on this one. Typed everything in right, didn't I? Yep. 0.7704. So, f inverse of 2 is 0.7704. Okay, that's just a piece of it. Find the actual inverse. Now I'm going to freeze my screen. Yes, because you're going to have to multiply something by 0.7704, but you don't have to drag out your computers. If you get to that point, I'll give you the answer in a second. So. Well, you're going to need me too much here, too. Okay. Alright. I was going to let you guys do this, but without the calculator, you need the calculator too much on this. Alright. So, I wrote this wrong. F inverse prime of 2 would be 1 over f prime of f inverse of 2. We found f inverse of 2. Here we got 0.7704. So now we need to find f prime of 0.7704. I do not know if I have shown you guys what the calculator can do as far as derivatives go here. In fact, if this is calculator active, and it pretty much would have to be for this, I'm gonna get rid of this. I'm gonna call this F right now. You definitely can find the derivative by hand and get 10x to the 4th plus 3x squared, and then you could type in 10 times 0.7704 to the 4th plus 3, 0.7704 to the 2nd. So we should be getting 5.3031 here in our denominator. But I don't know if I've shown you guys this on the on Desmos yet. If you have f of x here, you can find the derivative at a point by just typing in f prime of 0.7704. So you don't even have to do the derivative by hand. It finds the derivative for you and plugs that number in. So notice how we're getting like the same thing we would get here. So that, like if you're using this on a calculator active question, that is a shortcut that you can use. So let's see, we got 1 over 5.303. Since that's a decimal inside of a fraction, they probably would go ahead here and just do 1 divided by 1 divided by this number right here and get 0.188 or 189. Where's my here? Okay, questions? All right, a lot of times they're going to give you things like example 6 or example 7 where you have to use tables and things instead. Mm-hmm.
Could you leave it as like 1 over 10 times 7 or 0.774, like all of that?
You could not leave it. You could not leave it here because it's f prime, like you haven't evaluated that f prime yet. But you could definitely leave it as 1 over 5.303. Or if you had like plugged all that in, you could do 1 over 10 times 0.7704. They would give this to you on a calculator active question. So I would advise against doing 10 times 0.7704 to the 4th power plus 3 times, because you're writing so much there that if you make a mistake, like say you put to the 3rd power instead of the 4th power, then it's going to be wrong for that. So it would have to be calculator active. So what I would do is I would find f prime of 0.7704 on the calculator, and then I would probably do this and maybe leave it there. And since it have to be calculator active, it's not that big of a risk to take that last step and divide there, and that, I wouldn't think that would be foolish for this either. All right.
Would they usually say like how many decimal places you should round it to, and that way it's...
It is always on the AP exam, it's always 3 decimal places. You always have to be correct to at least 3. You can keep more if you want, but at least 3. During the problem, don't round at all. So like during the problem, copy and paste the answer to the next line, only round your final answer for that. Okay, that should be exponent right there too. I messed that up. So we are supposed to find f inverse prime of 8. So if I run through this one real quick, f inverse prime of 8. Like they give this as multiple choice questions sometimes. Like it's this basic, right? So if I've got f inverse prime of 8, that's going to be 1 over f prime of f inverse of 8. So you would be looking for f inverse of 8 first. To find f inverse of 8, you're looking for where your y value is 8, and you're looking for the x value that goes with it. So what's f inverse of 8? 3. F prime of 3. And then f prime of 3 is given to you. What is f prime of 3? F prime of 3 is right here. It equals 5. So we just replace this with 5. As long as you know the formula, that should be a very, very easy problem to you. The reason it ends up not being a lot of times on the actual AP exam is because it's been since October that we looked at it, and it's now May, and you guys still remember that formula. We'll try to review some, obviously, but you can see that. They a lot of times like to use G's here instead. The table above gives selected values of f of x and f prime of x. If g of x equals f inverse of x, find g prime of 6. They like to do this because the notation's a lot cleaner when they're asking you to find the derivative. I still don't like it. I like the inverse notation better because that's like how my formula looks in my head, and I can put that in there. So when they're asking for g prime of 6, they're really asking for f inverse prime of 6, right? So the formula for that is 1 over f prime of f inverse of 6. You don't necessarily have to go back to that. You could say this is 1 over f prime of g of 6, knowing that g is the inverse, but I just like the inverse notation better. It tells me what to do in my mind. It tells me, oh, that's your y coordinate. You need to find the x coordinate that goes with it. So what would f inverse of 6 be here? 2. Because right here, you're looking just at this f column. That's like your y column. You're going with the 2 that goes with it. So now we got 1 over f prime of 2. What is f prime of 2? 1/3. And dividing fractions is easy as pie. Flip second and multiply. 6, 8, and 3/2, those are all there to distract you. You don't use them at all for that. So I think we're pretty good here. I did throw a couple review things in here like 10 and 12, but I think I'm going to hold off on those for right now. Definitely 1 through 5. Let's do numbers 1 through 5, and then 14 is kind of like a challenge problem. Everybody needs to try something on 14. There. We're going to work on this some more tomorrow, too, because this has a lot of, like, review stuff. Not all of it is inverses on it, so we'll look at it some tomorrow. But this will give us some inverse practice right now. So 1 through 5 and number 14 are the only ones you have to do tonight. 1 through 5 and 14.